Hi, a quick tutorial for the Integrant library today. If you were following my videos for Clojure, I was mainly using a component to build the backbone of the application. But there is another library which is getting more and more popular recently, and it's called Integrant. And you can look at that as a component alternative with some small improvements, some new features. And we're going to take a look how to use it and discuss main differences between Integrant and component today. So to start, we need dependency for the library. This is Integrant 081 as the most recent version for now. And yeah, let's jump into the code straight away. So first of all, the goal of the library is to create a structure of our different components in our system. So an example could be an HTTP HTTP web server. Then we have like a connection pool. Then we have like a Kafka consumer, some threads, or some stateful objects that we want to describe as a component. And each component will have a start and stop lifecycle. So this is really similar to what a component library is offering. The key difference is that in component library we use Clojure records and we need to wrap our state inside the record and implement a lifecycle protocol which has start and stop method. Here we have our system described as Clojure data. So in this example, it is inlined in code. We have a key app server and key app data source. And then we have some data here that will be available to the start and stop function, to the start function when we start the system. And also here you can see that we're using this IG, which stands for Integrant Core, and we use this ref. And we are telling Integrant that for this key inside server, we want our component that will be created here. So when we run start function of app server, we will already have data source available because it will be started as a dependency before the server will start. So Integrant understands, same as component, the graph of your dependencies, of your components, and it starts it in correct order and it stops it in the reverse order. Okay, so this is just plain map so far. To connect this data structure that describes our system with a real code, we need to register some def methods. And again, from the Integrant core, and we are going to implement init key and halt key. And here we say which key, and then we have two params as an input. It will be a key name and options. And for now, we like in real application, what we will do here for a server is probably just start like a Jetty server, and for your database data source component, you'll create a connection pool. But now we'll just return some simple things but still it will show us how this works together. Okay, so we registered init key. It will print our params and it will just return Jetty key. For the stop, which is called halt key here, we will just print line that we stopping a specific key. And same for the data source. We printing that we started, and then we return like a fake connection pool. It will just like have a map that says pool and some string. And for stop, we're just printing that we're stopping the component. And here we create our system and we run this init on the config. So this config here, we run init on top of that. And we will, after we do that, let me clean the output. If I run this, you see that we have some print lines, and it says that we're starting data source first, and it makes sense because the server depends on this key, and it says like the key will be this one, and the opts, how we call them here, will be everything that was defined in our system config. So this part will be options that we receive. And you can imagine that, for example, if you have all these options, like JDBC URL, user, and password, in the init key for the data source, you'll use these options and create your connection pool. And then when we start the app/server, we will get our port, which comes again from here, but also we'll have our data source. And now this is interesting because now we'll have this pool, which is what init key for the data source returned. So in this ref, we'll have the actual object that was created in the init key of app data source. And after that, it's up to you how you use that from the opts. So for example, a real example of starting a server will be get these components that were passed as dependencies and put them as a middleware, for example, in your request context. So after that, the handlers that you write will have access to things like database and some other stuff like cache, Redis, or whatever you want to implement. To stop the system, there is IG halt on the system that we created. If we run that, we see that we're stopping our system components in reverse order. So we do the app server first, and then app data source after that. Usually, people just prefer not to put the config like this inside your code, but do the same thing, but in the EDN file. So here we have resources and then config.edn, and the structure here is exactly the same. The only difference is that for the reference, we're using the EDN tag literal with this IG/ref. And after that, we can do similar thing, but we're now reading the resource, and then we use integrant read string, which will read the configuration from the EDN. And after that, everything else will work exactly the same. So we still have the same system, and we can stop it, right? So everything is still working. The difference now is that we have it kind of outside of the code. And also, if you're using IRO, which is quite nice library for configuration, you can combine integrant system description with config definition. And I've stolen this example from one of the articles. I'll share the link as well. So here you see that we're using this env tag that comes from IRO, and we can use like the environment variable name here to render the port from the configuration, but also we use this IGREF that we're referencing other components, that is integrant config. And these top level keys, if we define these def methods from integrant for them, like init key and halt key, they'll be used by integrant to build the system. But also we can put some other top level keys. If we don't register integrant lifecycle functions for them, they'll be just plain configuration here. So we can just read a property from environment. Okay, so let's move to the next thing. For if you want to use IRO and integrant together, the only thing you need to do is you want to extend IRO reader and add this IGREF and create this ref inside. In that case, it just works without any other changes. And you can mix config and the system definition inside the same EDN file. And in more details, it is described, this approach is described in this article. To be fair, there is another approach that says probably that's not the best way of doing, of combining integrant and config in the same place. And it makes sense because it limits the flexibility a bit. But I think for most applications, this will just work fine. But if you really want to be extremely flexible, probably it's a good idea to split rendering config and creating the system into two different steps. So the first step will be read error config, and then you have this plain map just for the config, and then you pass it to the other function, and this function can build your integrant config, and then you can run integrant start on that config. So yeah, there's two approaches, but this is a nice one and will work in most of cases, I think. All right, the other difference from component is that you can easily start part of your system. So it's kind of possible in component as well, but you have to modify your system definition and probably create different versions for like test and dev, etc. But here it's really nice because this init function that starts the system can take optional param of keys that you want to start. So in our case, we want to start data source here, and our system will only contain our data source. So if I run this block, you see that we just starting data source and stopping the data source after that. So we don't care about the server. But if we switch this to database server, it will still work. And note that we don't need to specify data source because it will know that it depends on that, and it will start everything that it needs in addition to this key that you specify, which is really nice. So it's a really nice way of starting part of the system. One of the real world use cases for that is, for example, in your tests, you have a quite complex service, right? That has database, server, and then probably Kafka Stream, or some components. But for your specific test, you only want to start, let's say, a database connection, and that's it. So you can just use that and start your system with only data source. Or when you want like a full end-to-end test with Kafka HTTP server, you say that you start everything, and you don't have to create different systems for all these use cases, which is quite nice. And at the end, just an example of your entry point in your service. If you're using IRO and Integrant, that could look something like that. So we have defined this main function, and then we have a let. Then we're building the system. We're getting our IRO integrant config. Then we use IRO read config. So IRO will fill all these placeholders for the environment params. There are also a lot of features with IRO that you can use, for example, profiles. So you can define how your database configuration looks like in development, in production, in test, because this could be really different in all these environments. So you can pass like a profile here optionally in the read config. After this step, we'll have a map that defines our system, integrant system, and then we run integrant init. And this system just sits here. And the only thing we want to do as well is to add a shutdown hook for JVM. And add when JVM will receive these exit signals, it will call integrant hold system, and it will stop our system. And yeah, I think that's it. Just maybe a couple last thoughts. First of all, it is really similar to component. So if your project is already using component and you're quite happy with that, I don't think there is much value for you to spend time and refactor that. The only reason I'm looking into this now is because it's getting more and more popular. So if you're joining a company, quite high chance that they're using Integrant, and it's basically better to be prepared. And yeah, I think I try to describe this main features of Integrant here in this video. So let me know what you think. Thanks a lot for watching. Don't forget to subscribe, like and comment. That's really help. Also, there are always options to support my channel by buying me a coffee. See you next video. Bye bye.